Hello everyone. In this video we will be learning about read-only memories. In the last video we saw some basics of memory system. We saw some types of memory wherein we saw RAM, ROM, primary and secondary memory, cache memory and flash memory. So in this video we are specifically speaking about ROM. In the last video we saw something called as RAM, that is nothing but random access memory, which was a volatile memory, whereas RAM, once there is a data that is saved, the data will be cleared maybe after some time or once the processor is turned off with its power. But ROM is a non-volatile memory. It can hold data for a very long time. Let me say it can hold data for a very, very long time, just like your hard disk. So if we keep something in the hard disk, the data will remain in the hard disk for a very long time. When I say memory, memory is always an array, right? So we saw that in the last presentation. So the array will be consisting of a number of cells. Each of the cells will hold 1 bit of data. There is a very small difference or change with respect to ROM and RAM when compared to its design. The ROM is built with a different ideology compared to RAM. The ROM is volatile, so I have said before. So let me just go through the design and we will also learn about some of the properties of ROM. This is the design of the ROM, or read-only memory. So I will be specifying it as ROM. If you observe, as the same design with respect to RAM, there are two lines. One is word line, the other one is bit line. So whenever there is an address addressed to a memory, the address will come with word line and bit line or column line, you can say. We have only one transistor here. In the earlier design for RAM, we saw two transistors. The transistors with inverters, there was a different combination in RAM. Here we have only one transistor with a small switch which is operated with respect to different positions for different purposes. For logical 0 operation, the transistor is considered to be closed and it is grounded, whereas for logical 1 operation, the transistor remains open. This is about reading. When we want to write or store data, the P switch is toggled. So as specified in the diagram, when it is connected, it will store 0. When it is not connected, it will store 1. If you observe here, there is a small change, that is the transistor which is actually dealing with reading the data from any ROM is more important, because ROM mostly used for reading the data. So it can store the data that has been stored for a very long time, but it can read it. So reading is very much important. Writing is also an option available, but writing cannot be done directly. You may have to come up with a different idea for it. It means there are some assembly added things that are there with it to write data onto any memory or ROM. This transistor will behave to be the very important component for the overall operation of a ROM. Okay, so this is about 1 bit of data. So, same kind of design will be arranged in rows and columns to have or to give you more amount of data or data storage. So let us learn about ROM specifically. Okay, if you all observe, read-only memory is a non-volatile memory. That means it will not reset itself unless it is reset by the user, right? So the ROM allows the user to put data in it, and it allows the user to read the data in it. So let us say that when I say user, it will not be exactly a user. Instead, it's a processor. The operation is controlled by a user. So when I want something to be stored in the data, then only I ask my processor to do that job. So that is what it's all about. With respect to memory, the cache memory is located in the processor chip. With respect to when I say it is a primary cache. So we'll learn about that at the end when we are speaking about flash memory. So going ahead, there are many different types of ROM. When ROM was designed, it was designed with a very basic idea. Later on it was evolved day by day with many different properties. And we see 5 different types of ROM for now. The first one that we will be speaking about is programmable read-only memory. So it allows the data that can be loaded by the user and processor. It processes the data, whatever the data that is inserted into the memory, in an irreversible format. And then it stores the information with respect to any specific user, with respect to the data that is supplied by the user. And we all see that whatever the storing information is expensive is usually stored in ROM. Expensive means which should last for a long time. So if some data is there, if you're running something and on that instead a server goes off, and if the data is erased, whatever the work that you have done till that time would be of no use. So some expensive data. Data is important, call it as an expensive data, can be stored in ROM. And when it comes to erasable programmable read-only memory, so we can erase the data. So we can store the data and we can also erase it. Whereas in programmable read-only memory, we were not able to erase the data individually. So here we can do it. So we say this is a flexible device. So it is a programmable read-only memory, it is a erasable read-only memory, and it is a reprogrammable ROM. So it requires an expose to erase the data, UV light to be exposed on the ROM, or ROM is exposed to the UV light so that the data is erased. Then comes electrically erasable programmable read-only memory. So we cannot provide UV light for every data every time. Let us say you have a pen drive. So if I want to remove the data or erase the data in the pen drive, you cannot go and find a search for UV light, expose it on the pen drive, then the data will be erased, then use it for reprogramming. This is not working out for us, right? In the earlier days, it was a reason the idea came up on those days. So they were supposed to adjust with it, but today the generation is something different. We want things to be happening in a simple work, simple step. So here we don't need UV light to erase the data, right? So it can be easily removed. So the circuit or electrical circuit is capable of erasing the data that is there in the ROM. So that's why it is called as electrically erasable programmable read-only memory. Then comes flash memory. So it has the same approach to your electrically erasable programmable ROM, it is of a different kind. The content, whatever that is there in the flash memory, is of a different thing. When you want to read it, it will read only a single cell, but when you want to write it, it will write entire block of cells. That's a speciality, right? Push the data with more content, whereas extract the data one by one. And that is what the flash memory does. So flash devices, they have highest density when compared to ROM. So flash memory is a small different category when compared to ROM, but it actually comes under ROM. Okay? The flash devices, with respect to whatever that we will be using, they have the highest capacity and they have the low storage cost per bit. So as we were telling, memory, speed and cost, all three are important. Right? So if I say that the data rate is like 1 Mbps and I have the capability of holding 1 terabyte of data, but you should give me 1 lakh rupees. If I say that, nobody will be ready to purchase that. So in the same way, if I say that I have got only 1 Mbps speed, but I have got 2 terabyte of memory, but I'll give you for 1,000 rupees. Then also people will think about buying it, because once they by bit per second think about it, if I want to transfer one movie, I may have to wait for like 1 lakh seconds, right? So it is more than like 10 hours or 30 hours. It's not feasible for us. Nobody will be ready to accept that, right? So all three things are important. We will see about that also in the later coming, right? So power consumption of flash memory is very low. So that makes the flash memory to be more attractive and used in most of the applications nowadays. Single flash chips are not sufficient large because they cannot hold more amount of data. What they do is they put multiple flash chips together to make it a big memory device. So using flash cards or flash drives, it can be implemented. Large memory can be implemented. So as I said, speed, size and cost. It's important. Let us try to differentiate things. We have seen about RAM, we have seen about ROM. We will also see all those things that are written here, that is magnetic disk, in upcoming videos. So this dynamic RAM should also be considered with respect to the operations, right? All things important. So when it comes to speed, static RAM is very fast because it has got a very specific size of operation. So it knows which block of data to be keeping and it will respond immediately. So we have seen that 0, 128 and 256, all these bits are considered to be or addressed to the 0th memory in the cache. So things can be easily used. But magnetic disk, it's something like a different memory attached to processor. So it becomes a bit slow when it comes considered to be the operation. Okay? Size. SRAM is large because we have kept a lot of data in it and the size of it is very big. Dynamic RAM is small. Magnetic disk is actually still more small. The drives and all, they almost take the same size as DRAM. The cost, SRAM is expensive, DRAM is less expensive, and magnetic disk is low price. In CD, today you can get it for 2 rupees. So when it comes to the other things, like memory, speed, size and cost. So cache, we speak about cache, right? The other cache memory that will be there with respect to the other memories other than your processor chip is considered to be the secondary cache. Okay. So that means we have primary cache, it's the cache that is there in the processor chip. Secondary cache is the cache that is there with respect to any other memory other than processor chip. So we can see that comparison there. So this is how the hierarchy of the memory is considered. When size is decreasing, speed is increasing, and in cost is also increasing, right? So we need to consider that. This processor will have very low in size, but very high in cost and speed. So it works at a very fast rate. It is very costly also. When it comes to the highest memory, cost is very low. That's what we see. If you want to purchase a RAM of somewhere around like 2 GB, let us say, you need to pay 1,000 rupees. But if you want to purchase a hard disk, 1 or 500 GB, you will also pay almost something like 1K or 1.5K. So that's what the comparison is all about, right? So the magnetic disk secondary memory will include all that memories like your pen drive, your hard disk, external hard disk, your CD, DVD, Blu-ray disk, anything, right? All storing devices can be considered here. But when it comes to your virtual memory or your cloud memory, they are even cheaper, right? So that's the speciality of memory. So when it comes to the point of memory is something that is very much comes with very different ideas, right? So memory comes with multiple things. So they have got size, how much data it can hold, speed, at what rate it can extract the data or write the data. So there are many different things. When you want to extract data, you can do it fast. When you want to write the data, it takes a bit of time, right? So let me say, like, if you want to watch a video, the video will be loaded very fast to your player. But if you want to write a video onto the memory or your hard disk, it takes a bit of time, right? That's what